Hello everyone, welcome to Equal To, and this is episode 18 of our Polynomials playlist. And in the previous video we saw a few algebraic identities, right? And we saw one more example as well, which was using the algebraic identities to solve it. Now we are going to see a few more examples here, two more examples here. So basically these are going to be in the same section as well, so you're going to use those identities to solve this. So if you haven't watched the previous video yet, that is very important for you to understand this video. So please go and watch that before watching this video. Okay, so example 12. Evaluate 105 into 106 without using multiplication directly. Okay, so 105 into 106, you are going to find the value of this product, but you are not supposed to multiply it directly. So how do we find that? Okay, so a simple trick is, these are numbers that are so close to 100, right? So what you can do is, you can write it as a sum of two numbers of which one is 100. Okay, so it can be written as 100 plus 5 into 100 plus 6, right? Because these are very close to 100, you are writing it as 100 plus 5 into 100 plus 6. Now this is very similar to an identity that we know. The identity is x plus a into x plus b. Right, x plus a into x plus b is equal to x squared plus a plus b x plus ab. Right, we know this identity. By using this identity, you can evaluate this easily. Okay, in this case, x is equal to 100, a is equal to 5 and b is equal to 6. Okay, now we are just going to plug these values into these identities. Okay, so x squared is 10000, so that is going to be 10,000 plus a plus b into x. A plus b is 11, right? 5 plus 6 is 11. So 11 into x is 100 and plus ab. So 5 times 6 is 30. So we're basically going to add these numbers. This is 10,000 plus this is 1100 plus this is 30. So adding this, you will have 11,130, and that is going to be the answer. You can verify this as well by multiplying it directly, or let me just do it right here. 105 into 106, it's going to take a lot of time. 0, 3 and 3 here, so that is going to be 6, and it's going to be 0, 0 and 0, and then again 105, right? 5, 0, 1, 0, 3, 11, 1, 1. Yeah, so the answer is basically the same, and I think I have, okay, I'll just move this aside. Okay, so answer basically comes out to be the same, but using this identity you can find this a lot quicker. Okay, so it's easier for you to do this using the identity, and the identity is x plus a into x plus b. Okay, now moving on to the next example. I hope you understood this. I'm not rushing, but this is very simple. There is nothing for me to explain a lot here. We are just expressing it in the form of x plus a into x plus b and just using that identity. Moving on to the next example, example 13, factorize, and we have two subdivisions here. So the first subdivision is 49a squared plus 70ab plus 25b squared. Okay, now to solve this question, we are just going to use a little bit of intuition and stuff. Okay, so this 49a squared, it can be written as 7a the whole squared. How can it be done? Because 49, as we know, is 7 squared, right? 7 times 7 is 49. So 49a squared, it can be written as 7a the whole squared. Okay, and then the 70ab, let that be 70ab for now. Okay, this 25b squared can be written as 5b the whole squared. How can it be done? Because 25 is 5 squared. Okay, so 25b squared can be written as 5b the whole squared. Now this is right, this is like a squared plus some term plus b squared. Now we know there is an identity called x plus y the whole squared, right? We know there is something called x plus y the whole square, and it is x squared plus 2xy plus y squared. So what you're going to do is you're going to check if this expression that we have in this question, whether it can be expressed in this form of x plus y the whole square. Okay, now in the place of x we have 7a. In the place of y we have 5b. Okay, and the second term should be 2xy, right? So it should be 2 into 7a into 5b. 2 into 7 is 14, 14 times 5 is 70, or rather 7 into 5 is 35 and 35 times 2 is 70. Okay, so the 70ab is basically 2xy for this expression. So 7a the whole square plus 2 into 7a into 5b plus 5b the whole square. Okay, so a square plus 2ab plus b square. So this can be further simplified as 7a plus 5b the whole square. Okay, so 49a square plus 70ab plus 25b square, we have converted it into 7a plus 5b the whole square. Now 7a plus 5b the whole square is basically 7a plus 5b into 7a plus 5b. Okay, why are we splitting it and writing it? Because that is how you express a polynomial in its factorized form. Okay, 7a plus 5b into 7a plus 5b. So by using algebraic identities, you can easily factorize a polynomial. Okay, so I hope you understood this. This is very easy as well. And moving to the next subdivision, that is also going to be very similar to the question that we just solved. Okay, so we have 25 by 4x squared minus y squared by 9. 25 is 5 squared, right? And 4 is 2 squared. 9 is 3 squared. Okay, so this can be written as 5 by 2 x the whole square minus y by 3 the whole square, right? It's quite obvious for you at this point. 25 is 5 squared, 4 is 2 squared, 9 is 3 squared. So you have written it as 5 by 2 x the whole squared minus y by 3 the whole squared. So this is of the form x squared minus y squared, and that is equal to x plus y into x minus y, right? This is an identity that we know. So you're just going to express it in that form. So it's 5 by 2 x plus y by 3 multiplied by 5 by 2 x minus y by 3. Okay, and this is the factorized form of this subdivision. Okay, so I have solved two examples in this video. One is evaluating using our algebraic identity without directly multiplying, and the second one is factorizing a polynomial using algebraic identities. Okay, now for you to solve these kind of questions, you have to remember these identities, okay, that we have seen in the previous video. I hope you have watched it. Okay, so just revise it once again, and so that you can remember these identities well. Only then we can solve these questions easily. Okay, so I hope you understood this. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.